Hi everyone, I'm Brandy and I work with the Bruce County Public Library. Today I'm here in the Cargill branch and we are going to do our STEAM Online activity, and it's going to be a Builders Club theme. And no matter what kind of activity kit you love to play with, whether you have Lego, Meccano, whether you love to do Play-Doh, maybe you like to construct things out of construction paper, cardboard, whatever materials you like to build with, we are going to try a challenge today, and that is to build a bridge. So I'm going to show you a few different ways that you could build a bridge with some of the different materials, and then we're going to talk about how we can test the construction of our bridge, some of the physics and the materials to see things we can do differently to make them stronger or bigger, and we're going to do that now. Okay, so here is my little builder's lab here in the Cargill branch. I've got a bunch of different bridges with different designs and different materials all set up. And here's the first one we're going to look at. So I've made this out of clay, like a Play-Doh, and I've got two sort of cylindrical columns here and a flat piece, sort of our deck of the bridge. And we're going to try adding one of my blocks to see how it holds up. So it can kind of hold one block. It looks like it's starting to tilt a bit. Let's try one more. Definitely can't hold much more than that. It's really not a very stable material. I mean, it's really pliable, right? And it's still really soft. It's not rigid at all. So that was an interesting test. Maybe you can build a better bridge than me with some clay or Play-Doh. My second design here is with a bit of clay or Play-Doh, and some bent straws. I haven't used a lot of them, I've just used two, but this is a little prototype to see what happens if I add some things to it. Again, it's not very level, so I don't know how much I'll be able to add or how much it will hold, but if I add another block, what's gonna happen? Oh, things start shifting. That Play-Doh is not solid enough in the bottom to really hold these straws in a very sturdy way. So, but still interesting, right? Science and technology and engineering is all about trying different things out, seeing what happens. So toilet paper tubes, you probably have these at your house. I get a lot of them at my house. And I just have some long popsicle sticks here. And let's do some blocks and see how much this design will hold. So we've got 1, 2, 3. Oh, it's getting a bit wobbly, but nothing has shifted yet. 4. This is pretty strong, I think. It's getting tippy, but it really can hold. There you can see that's 5 blocks. I'm going to add 6 blocks, and that can hold them. That's a really strong construction for a bridge. You know, the toilet paper rolls, they're very large around, so they really add a lot of stability. If it was thin, like a straw, that wouldn't be as stable, but this, it's actually really hard to tip it over. So it adds a lot of stability, that wide base. And then this wood as a material is quite strong. It's holding a lot of blocks there. I'm pretty impressed. So we will take those down and try out a couple of other materials here. So I also had a piece of an egg carton. This is the top of an egg carton. I just put it between some stacks of books, and I've got 2 books there on top. Junior chapter books, and let's just see how many. We've got 2 there, how many this will hold. It's already bowing a little bit in the center. You can see I purposefully kept my sort of pillars, my base far apart, just to see what would happen to make this a little bit weaker. If it was closer together, it would be a lot stronger. It's really not bowing at all, but let's see. If we spread it farther apart, I just wanted to test it to see how many books we could get on here. So I've got 2, 3, 4, oh, it's starting to sink a bit, 5, 6. Now my load, my books, is over a little bit on this side. If it was really in the middle, which I think I'm going to test it, because that's important to test, the weakest part of your build. So I've got 6 here. Let's keep adding. 7, 8, 9. This is a heavy book. Oh, there, it cracked. So that's how much weight an upside down top of an egg carton can hold when it's sort of stretched to the max for the base. So there you go. Now it definitely bounced back, but it has a weakness now. That crack is there. So that was a neat experiment. I think that this toilet paper and some cardboard is probably going to be really similar to the popsicle sticks that we used. But let's just see if it can hold the same number of books that we tried on our egg carton. So I've got 4 here. And it looks like I might not have spaced that evenly. And that's another thing to think about with the base of your bridge, is that things are really evenly spaced out so that the weight can be evenly distributed. So there's 7, 8, 9. Again, I'm trying to keep things pretty much in the center. 10, and that really has no trouble holding the weight of those books. Toilet paper rolls are a really strong base, and then I've got those pieces of cardboard as my my deck or my plate, and wow, it's really doing a good job of holding it. Okay, now I have some Lego, and I think this will be kind of fun. We've got 2 different concepts of construction here, pretty similar, but in this one, and I didn't use a lot of vehicles to test, I really wanted to test for weight. In this one, I just used a base plate and some 2x6 or 4x4 or 2x2 blocks, and just made 2 pillars evenly on the end, and they're pretty wide on the bottom, so they should be pretty strong. I'm not going to test this with too many books, but I think because this one is pretty strong, it's going to hold a few. I don't want to bend my base plates. That happens at my house sometimes and people get upset. So, oh, now see, I didn't set that on the center and it just slid right off. So this is actually a bit of a tippy design because the top or the deck of the bridge is wider than the base. And when the base is wider, it's going to offer more support. So that's what happened. That's kind of interesting. Now I want to see what this other style of a build is like here. So I used the same kind of base. I used 2 plates together. You can see here, there's 2. And I added a bit of reinforcement with these pieces underneath just to see how that would hold up. Now I'm doing everything one-handed here because I've got the camera in my hand just so we can get a little closer up. And I'm going to add a couple books and see what happens. These ones are pretty light. And I'm going to set them, well, let's try them like this. Oh, again, it's a little tippy. I wasn't expecting it to be tippy. And it's already sagging quite a bit. You can see here our bases are tipping up. And I add another book to that, it's probably going to break, but it's holding. I'm just gonna add 3 at once and see what happens. Oh, wow, it's holding, but it definitely doesn't look stable. And I think if I tip it a bit, oh yeah, that's really starting to put some pressure on those reinforcement pieces I put in the middle. So let's take the books off and see. Oh, it really held together, but I can see that it really bent in this part. So maybe you could think about an idea that would help reinforce that. And I actually thought of one ahead of time, and I decided I would add this little pillar here and see what happens. So I'm just gonna set that on top. I'm actually gonna turn the whole thing over and stick this on, okay? So now I have a support in the center, and already I can feel that the center is so much stronger than these points between the bases. So I don't think this is going to shift at all. It's still tippy, And that is a really interesting lesson for building bridges, is making sure our base is as wide as our deck of the bridge. And look at, I'm adding all of these chapter books. Some of these are the heaviest ones. And it really isn't shifting. These base pieces, these pillar pieces are not lifting up. The middle is not shifting under the weight. So that's pretty cool. We've done a little bit of investigation here to see what materials would be strong for different bridge types, and what styles of design make the best and strongest bridge. So this egg carton, it's not really a solid piece of material at all. And in fact, it has a crack now. So that wouldn't be a good choice for a sturdy bridge, but something like this cardboard, and you can see it's corrugated. There's a reason they corrugate that. The extra pieces that they add between each layer, and this is like 2 sets of corrugated cardboard glued together, makes this super strong and really hard to bend. So some materials like that can really make for a stronger bridge or structure. And then I think that we found our toilet paper tubes, because they're so wide and really sturdy, because the bottoms are really flat and it's hard to tip them over, that I think this style was really our strongest bridge. The Lego might have been the prettiest or the coolest, because there's so much cool color you can build with Lego, and I think we could have added some more pieces to make it even more stable. But this was a fun activity for our Builders Club theme on STEAM Online. So grab some of your favorite building materials, whatever they are, and see what you can design for a bridge, and test it out and see how strong it is and how you can modify your design to make it stronger, or maybe even bigger. Maybe you want to take a bridge across the room, or between 2 pieces of furniture, across the sink, something like that. See what you can do to make a really neat structure out of some of your favorite building materials. Thanks for joining us. Bye.